Welcome back. So in the previous tutorial, we learned NumPy and saw how arrays make numerical operations much easier and faster. But when we start working with real-world data set, our data usually doesn't look like a simple array. Okay, we have names, departments, cities, dates, marks, and so many columns of data. Imagine working with a lot of data written in Excel sheets, CSV files, and you want to have some insights from the data. This is where pandas become extremely useful. So in this tutorial, we are going to learn pandas and we are going to do it practically in Google Colab. So what we'll be doing data frames. Okay, we'll be inspecting the data, how it look like. We'll select some data, filter out some rows from a large collection of data. We will filter out some rows. We will handle if there is any missing data and we want to fill those missing values or remove them. We also create in the existing data maybe new columns or the derived features. We also would like to see how we can group data so that we can see aggregated information from that data. We will try creating our small own data set and then we will have CSV files. We will try to upload them and finally we will also see how to merge two different data sets into one and get some insights from it. Okay, so we will be doing everything practically in Google Colab. So let's get started. What is pandas? So Panda is basically a Python library, just like your NumPy. It's also a Python library. You import it as import pandas as PD. It is very generic. So everybody uses it like PD. So it is an alias. Okay, so it's a short now. So whenever you want to use any functions from this library, you will simply write pd.function name followed by the brackets. Okay, so the pandas basically gives us the power to handle the Excel sheets, CSV files or the large data. So mainly it is used for data manipulation and data analysis. Okay. So if you think as NumPy gives us powerful numerical arrays, then Pandas gives us powerful structures for working with the tabular data. Think about an Excel spreadsheet. You have rows, you have columns, you have labels of each column. Now Pandas basically provide you a programmable version of that CSV data or that Excel sheet. Okay. So there are two important structures of pandas. One is series and other one is data frame. Okay. So what we want basically is instead of only numerical arrays, we want the complete data in CSV file which is having rows and columns. Each column have some labels. Okay, so this is my tabular data. I want to handle this using pandas. So we can have clear analysis, faster exploration and easy preparation. Okay, so if there is an Excel sheet, we can simply use it as a programmable spreadsheet using much more power of pandas. Okay, so how do we use it? You will simply write import pandas as PD and you will start creating a data frame. What data frame is, how to create that, we will see it right away. Okay, so as I just told you that there are two core pandas structures, one is series and one is data frame. So series is basically a single labeled column. Okay, it is a single sequence of values which is having some index, maybe the index, its name. So Aman, Ria, Kabir, this is a single series. It is basically in 1D. So series are 1D. If you have rows and columns and every column has some name, then it is basically a spreadsheet or a table. You can say tabulated data in 2D. So data frame is 2D. Maybe you have some columns, name and math and AI. These are the marks of the subjects. Each column has some values. Okay. So first one is maybe the name is Aman, marks in maths are 78, marks in AI are 85. Second data point Ria, marks 92, 88. Third data point Kabir, 65, 78. So these data points are called as rows and these features are called as columns. Every feature has its own name, which is the name of the column. Okay, so this is how we can say that data frame is basically collection of some columns. So most of our pandas work will involve data frame only. Okay, so let us now directly see how to import pandas and create a data frame. Okay, now imagine I want to create this data frame. Okay, for that I will import pandas as pd. I will say, okay, this is the data. My data is equal to having 3 rows. Okay, each row has name, marks and city name. Next row, its name, marks and city. Next row again, name, marks and city. How will I create it? I will use the dictionaries here. Okay, the dictionary key will become my column name and the dictionary values will become the row values or the list. So if I want to create this data, okay, I will write it as data. So my data would be here. So in my data, there are 3 columns. One is name, then marks, then city. Okay, these are strings. So I will write it as, okay, these quotations. And then in each of them, because these are name of the columns, in each of them, what I would write is, a list of data. Okay, in name, my entries are Aman, comma, Ria, comma, Kabir. In marks, again, there is one more list which is having 72, 92, 65 entries. In city, one more list which contains all the string values, which is Delhi, Patiala and Ludhiana. Once the data is created like this, I will simply say, okay, now I want to convert this data into a data frame that can be handled by pandas. So write pd.dataframe of this data and your data frame df is created. Okay, so let's try to do it in Google Colab. So in this particular hands-on, we will be using CSV files. There are 2 CSV files we are going to use. So I will first show you how to upload the CSV file and then we will start working on it. Okay. So in Google Colab, you will simply use the from Google Colab import files and file.upload function. Once you run this cell, you will see it will give you this choose file option. So you choose it from your local repository, maybe the Pandas students, and you open it. The file will be uploaded here. Okay. Now to read this file, you use the function pandas.pd.readcsv. Okay. So it will take all your data into this data frame. So now I haven't created this data frame. Instead, what I have done is I have used the existing data, uploaded it and converted it to a data frame. So df.head basically, it shows you first 5 rows of your data. So basically you get to know what your data is all about, how it looks, what are all the columns and how does entries look like. So my Pandas student CSV file contains a lots of entries and its first 5 entries are 0, 1, 2, 3, 4, which have student ID, name, department, city, marks of maths, AI, their enrollment date and whether they pass the subject or not. This is the whole lot of data I'm having and I have shown here only 5 rows. If you want more rows, then in the head, df.head, you can simply write say 10. So it will give you 10 first 10 rows. Okay, 0 to 9. But if you want to see the last 5 or 10 rows, say maybe say last 3 rows. Okay, then it will give you last 3 rows. We have 20 good records. So these are last 3 rows. This is how you basically see the data. Okay. So here we have created the data. Now before we inspect and analyze it, we should know what our data is all about. How do we see the names and the columns, the size and let us take the complete stats of the data. Okay, so how do you do it? So there are some functions, df.head that I just told, it gives you first 5 rows of the data by default. If you want to change the number of rows, just in this argument, write the number. df.tail, it gives you last 5 rows of your data. Okay, then df.shape. What is df.shape? df.shape is basically gives you rows and columns. Like if there are say rows, comma, columns, this is what it gives. Okay, if there are say we had 20 rows and 8 columns, it will give you 20 by 8. Okay, also then there is df.columns. df.columns, we can see what are all the names of the columns. Okay, we can see the column names using df.columns. It will give you, okay, the column name is enrollment ID, column name was marks, column name was passed, whatever the column names are, it will give you all of that. Okay. Also, we can use df.info, which gives us the complete information about all the data types and any missing values. Then finally, df.describe, what this function is useful for. This gives us statistical information about the numerical columns. Okay. So maybe the mean value, median value, mode value, all these values will be given by describe, the standard deviation. So there is a very useful habit. You simply check with the head, okay, after loading the data. So head basically gives you the first 5 columns, then you check its shape, then you basically take like which all columns are there, then your info, then describe. So these functions you should generally use. Okay. So how do you do that in Google Colab? Okay. So you simply write like this, df.shape, okay, df.columns. So it will give you the shape and the columns, like the columns are student ID, name, department, city, math score, all these columns it has given. Okay. Then df.dtypes. Dtypes basically gives you data type of each of the columns. Okay. Then df.head we have printed, df.tail we have printed, we have already seen it. df.info gives you all the info, like there are 20 entries, the name of the columns, how many values are there, like if there are 20 values, are all 20 present or there are some missing or something. Okay, then data type, everything is given in this. df.describe basically give you the count, mean, standard deviation, min value, 25th percentile, 50th percentile, 75th percentile, max value, all these things. Okay. Now selecting a column. So what basically we want to do is, if we have the entire data set, from this entire data set, I just want this particular column, not everything. So if you want to choose a particular column, you simply write from my data frame, I want this column, give the column name, maybe marks. It will give you only this column, marks column. Okay. If you want to have more than 2 columns, then separate it by comma, but then there will be double brackets. Okay. I want marks and maybe the name. Okay. So that's how you take two columns from. So there are 2 brackets when we want to use multiple columns. Now next is loc and iloc, which is basically for location. This is for we have selected column. What if I want to select some particular rows? Okay. For selecting different rows, we use loc function or iloc. Now what is this loc and iloc? Loc works primarily with the labels and iloc works with integer values or integer positions. Okay. So for example, iloc of 0 gives the 0th row, 0th position value, which is my first row. Okay. And iloc of 0 to 3 gives us row number 0, 1, 2. So if I write iloc 0 to 3, then it gives us row number 0, 1, 2. Okay. And if I write loc 0, then it basically selects the rows whose label is 0. Okay. So a simple way to remember is location, loc is labels and iloc is basically the integer position. Okay. So let us see how we do it here. So for selecting the columns, I just write the name. Okay. I have written the name as math. So I only want the math column, which has come here in marks. Now I will print the header of it. Okay. So it will give me first 5 rows of marks column only. So here it is 78, 92, 65, 88 and 74. Next I have done selected, where I have taken name, department, math, AI score, these 4 columns. Out of 8 columns, I am taking these 4 columns in my selected new data frame. Okay. And I am printing its head. So how will it look like? It will look like this. These are the first 5 rows, name, department, math and AI score of these first 5 students. Loc and iloc, if I use iloc of 0, it will give me first row, iloc of 0 to 3. Then, okay, here it is. iloc of 0 to 3, it will basically give you first 2 rows, 0, 1, 2, first 3 rows. Okay. Then rows with 4, label 4 if you want. Okay. Then you will simply write loc instead of iloc. Okay. So it will give you all the rows with label 4. Okay. Next is filtering. This is very important. It basically, it is same like using in DBMS. We want to use, for example, for the real world questions. Suppose I want only those students whose math score is greater than 80. Then we can write, okay, I want the data from the data frame column maths. Okay, I want value greater than 80. Now this is my condition. Okay, I want this condition to be passed to my actual data frame of condition. This I want to print. Or instead you can write df of df maths greater than 80. This can also be written. Okay, so this will give me all the values where math score is greater than 80. So Pandas evaluate this condition for every row and return only those rows where this condition is true. So let us try another one. Maybe df.city. Okay, so if I write df of df city maybe equal to Patiala. Okay, so give me all those rows. Then it will print the rows where this condition is true and otherwise just simply discards other. What if I want two conditions? I want city equal to Patiala and maths marks greater than 80. Then I will write these two conditions and in between I will write ampersand symbol, basically and operation, A and D and operation. Okay, this is really useful when working with the real data set. So here, if I'm writing df marks greater than 80 and city is equal to Patiala, print all those values. So here it has checked, it has taken first the marks greater than, first check the marks greater than 80. Okay, this is the column, and city Patiala, okay, this is the column. So only one row is here. Okay. Another important attribute is in. So is-in attribute basically checks whether something is present there or not. So if I check df city dot is in Patiala and Delhi, if Patiala and Delhi are present, it will return true, otherwise it will return false. Okay. So let us see how it works here. So we have written like df of maths greater than 80. So it will give me all the values where marks are greater than 80. So here you can see all the marks are greater than 80. Okay, next I have checked city is equal to Patiala. So it will give me all the rows where city equal to Patiala. Here you can see that. Okay. Now I want two conditions. So my top students are where these both conditions are met, marks greater than 80 and AI score is greater than 85. Okay. Then I will simply separate it with ampersand and it will give me, okay, here the marks of maths are greater than 80 and AI score is greater than 85. So these rows it has selected. So this is called as filtering. Then we can, maybe we want to sort the data. We want to find the students with the highest math scores. Okay, so for that we can simply write df.sort values function. df.sort values. Okay, which attribute I want to sort? Okay, maths attribute, that is my math feature. Then ascending is equal to false basically means highest to lowest. Okay, if you only want first 10 entries, because in ascending order there could be a lot of entries, if you want only first 10 entries, then I write head 10. So this pattern is very useful in data analysis. For example, top customers, top products, highest salaries, best performing students, etc. Okay, so next is transforming our data. For example, we already have some information. My data is there. I already have some columns. I want to append new column here. Okay, this is my new column. So this new column could be maybe total marks. So I'll be using existing features and having some operation on them and storing it here. Okay, this can also be done. So maybe I have created a new feature, maybe past. So in this, I will assign the values where data frame of marks greater than equal to 40. So these will be assigned to this new column. Okay, so marks original are 78, 92, 65. New column past I have added by writing this condition where marks are greater than 40. So it will keep writing true, true, false, whatever is there. So because all of them are greater than 40, it has written all of them as true. Okay, maybe I can have one more feature appended here, maybe bonus marks or a derived feature. So where I'm writing bonus is equal to marks into 10%, 0.10. Okay, so it has given me another feature. So this way we can basically have more columns. So it basically, we don't have to write a complete loop to add one more column. This is the reason why Pandas is so convenient. Okay. So let us see. Sorting we have seen. Here we write new columns. Okay. So maybe I want to add new column total, where marks are equal to maths marks plus total marks. Maybe another column average, where we can see, okay, it is total divided by 2. And now I want to see all these columns. So I want the data frame where name, maths, AI score, total and average, these are there. And because I'm printing dot head, so it will give me only first 5 rows. So here it is. Okay. We can also add one more column. Maybe I want to create a result column for whether a student passes if average is greater than 60. So for that, I will check np.where. Okay, select all those rows where average is greater than is equal to 60. So, okay, average greater than 60, and write the pass, otherwise write the fail. So here we have printed name, average and result. Wherever average is greater than 60, it will write pass, otherwise it will write fail. And for NaN also it will write fail. Okay. Now these NaNs are basically missing values. Let us talk about NaNs and the missing data. So real world data, because there is a lot of data and it's really messy. So our data set deliberately contains some missing values, whatever data set we are using. So how do you tackle with that missing values? Okay. So for example, in this data, these marks, maths marks of Riya are NaN, Kabir's AI marks are NaN. So we have deliberately added that, but in general, real world data has some missing values, some problems. Okay. So we check it whether there is there any NA value, is NA. So this is the function to check if there is any NA value. So first we detect the missing values, then either we remove it or fill it. Okay. So missing data basically must be handled, and there are a lot of ways to handle the missing data. First we check it. So we will write dataframe.isNA or isNA.sum, which will give me the total values which are missing, total of values which are missing in the entire column. So maybe an entire column has 10 missing values. So sum will give me, okay, values 10 values are missing. So how to deal with these missing values? There are so many ways. So first way could be, I will simply remove the rows where any value is NaN. So this will basically create information loss, right? So if there are say 10,000 rows and maybe 4 or 5 have missing values, then I might say, okay, let me remove them. It won't be that much of information loss. I already have a lot of data. But if the data set is small, or if there are a lot of missing values, then you cannot simply remove it. Okay. Then what to do? Instead, fill the missing values. Now, filling missing values there are different ways to fill missing values. One is doing it manually. Okay. Second, doing it by imputation. So you can impute either some mean, median, mode, some stat values, or you can impute using model-based approach like k nearest neighbors. Okay, so there are different ways to fill missing values. So manually, you definitely need the field expert. For imputation, based upon some stats, okay, take the average of or mean value of the entire column and keep filling wherever the value is missing. Or if there is no numeric values, maybe you have taken mode, or you say, okay, just see like the recent values, like maybe 5 neighborhood values, whatever they are containing. Let me take the first 5 values and take their average and fill it. So we don't have to blindly fill every missing value with the mean. The correct strategy of filling the missing value totally depends upon the data set and the meaning of the missing value. Okay. Next is group by. So first let's try to do this missing values. So first we checked for the entire data frame isNA and sum. So for isNA will check the missing values and sum will give me the total number of missing values for each column. So column name has 0 missing values, column department has 0 missing values, column city has 0 missing values. There are 2 missing values in math score, 1 missing value is in AI score, and so on. Okay. Then you can also see it axis wise, like we discussed axis, right? X is equal to 1, X is equal to 0. Okay. So you can find it axis wise, like where the values are missing. Okay. So I want x is equal to 1. So it will basically print me the rows where there are missing values. So it will print all the rows where there are is NA or where there are missing values. So it has printed these 3 rows. It has 1 or 2 missing values. Okay. Now filling the missing values, we can either use column mean. So here we have taken this column df.math and taken its mean using the mean function, and we have filled it in this column. Similarly, we have done it for dfai score.mean. We have filled it in dfai score. Okay. And finally checked it again whether any missing value is remaining. So it says no, everything is 0. Okay. Next is group by. What is group by? So it is very important concept. Suppose you want to know the average score of every department. Okay. So you can write, okay, df.group by, group it by department. Department name is math and take its mean value. Or you can take maybe 2 departments and the average AI score. Okay. So very useful concept is split the data, analyze it and combine it. So we split data into groups, we analyze each group and the pandas gives us the result. So we can use multiple statistics like group by department, average, and then aggregate it over mean or max or min or count. Okay. So this same technique can be used for sales by department, maybe revenue by city, customers by category, then average sale or average salary by job role, and hundreds of other problems. Okay. So here we have tried grouping it by city. So it will give me stats city wise. So whatever rows had Ludhiana value, okay, it will give me mean value, min value, max and count of all these. Okay. We have taken the stats. Okay. Another very important is value counts. So I have unintentionally written hyphen here. Next, very important is value count. So this tells us how many students belong to each department or how many students belong to each city. Okay. So maybe we can say how many students come from city, Patiala, Delhi and whatever cities are there. So it will give me DF department dot value count. So AI department has 7 values, DS department has 7, cyber department has 6. City-wise students, Patiala 6, Delhi 5, Ludhiana 5, Chandigarh 4, like that. Okay. We can also give multiple conditions like for is in, which we have already discussed, whether city is in Patiala and or Delhi. So it will give us. Next is the dates. So our data set contains enrollment date column. We saw it, but initially Panda may read it as a text. Okay. So we have to convert it into a proper date time. So for that you will write 2 date time. So the enrollment date. So enrollment date will be converted into date time mode, date time type. Okay. So I have written date type, to date type. Then it will give me the actual date time. Now I can even extract some information from date. Maybe I want the month only, date dt.year or maybe day. So it becomes extremely useful when working with time-based data sets. Okay. So if I want dt.month, it will give me only the month. Okay. So is group by, then is aggregation. We can aggregate it by mean or max or min or count. Okay. So mean basically use the average, max is the highest, min is the lowest, count is how many values are there. So, okay. So it basically gives us many useful summaries of the data. It is grouping the data based upon the criteria I am giving and then aggregating the information in just one line, which becomes extremely useful. Okay. So another important thing is we might have 2 data sets and we want to merge it. For example, I have one spreadsheet of students where the student roll number, name and their marks of each subject are given. The second spreadsheet I might have is students roll number, name, whether their fees has come or not, in which month it came, or where the student comes from, the city or other personal information. Now I want to merge these both sheets. So this is called as data integration. I want to integrate data into one common spreadsheet. So there would be something in common, maybe the enrollment ID or the roll number. So based upon that, it will simply stack the columns which were not already present in the first sheet. So the combined sheet will have everything there. Okay. Okay. So for that we use pandas.merge. Let me show you how to do that. Okay, another important I forgot to discuss is removing duplicates. If there are any duplicate rows, we can use the function duplicated, df.duplicated. If there are 0 duplicate rows, because in our case it is 0, we don't need. Okay, so I want to merge it with another data set. So I will run the file, another file.upload. So let me choose the file. This is another file, fees of the students. Okay, now it is getting uploaded. Once it is uploaded, I will see, okay, in this file there are first 5 entries are student ID and their annual fees. Now I will merge them using pd.merge. I will merge data frame, my earlier data frame, and this data frame which name is fees. Okay, it is fees. I am merging them based upon the key value which is student ID. And how I am merging it? Left. Okay. So final merged one will have student ID, name, department, and rest of the features in the previous data set. So there were 8 of the total features. Alongside, one more feature or column will be added, which is annual fees. Now I want to print not all 9, but these 4 features: student ID, name, department, and annual fees. And I want to see only first 10 rows of it. So here they are. Okay. Now you have to answer these questions using pandas. So which student has the highest average? Okay. What is the average math score by department? Which city has the highest average AI score? How many students are there in each department? Find all the students whose average is above 85 and rest of these questions using the same Excel sheet, same CSV. Okay. So the pattern that you must learn. Okay, let us step back. So this is how we merged. This is one table. This is another table. I am merging it on the base of ID. So the final table will contain, okay, ID, name from here, department from here, marks from here, and grades from here. Okay. So there must be one common key value on which it will be combined. Okay. So typical pandas project basically follows this pattern. First, we load the CSV file using read CSV. We are reading the data. Then we are inspecting. We are understanding its structure using head, info, describe. Okay. Then we clean the data. We basically handle missing or incorrect values. Then we transform the data. Maybe we want to do some sorting, some filtering. We want to add some columns or something. Then we finally analyze it using some stats. Okay. Once everything is done, we will save and export the clean data or the processed data. Okay. So in this tutorial, we learned about series, we learned about data frames, how do we inspect data, how to do selecting, how we filter data, how to sort data, how to create new columns, how we basically handle missing values, then grouping and aggregation, how to work with dates, and then we basically saw how to read the CSV file, merge different columns, clean the data, and analyze the data. Okay, so now that we can analyze data with the pandas, the next tutorial and the natural step is to visualize the data. That's where the matplotlib comes in. So that we'll be seeing in the next tutorial. Okay, see you in the next tutorial.